Hello and welcome. This is going to be our lecture video for March 3rd through March 4th. We're going to be going over step-by-step binary lesson today. So let's go ahead and get started. Go a little more dim than that. So solve each system by graphing. So we want to find the combination of an x and a y value that makes both of these equations true at the same time. One of the easiest ways to do that, if you have a piece of graph paper, is to graph both of equations and just see where they intersect. So step one. All right, step one would be to convert each equation into y equals mx plus b. If needed. And often they'll already be given in y equals mx plus b, but just in case, that's why this is step one. We want to convert that to y equals mx plus b. Step two, all right, use m and b to graph each equation. So what I mean by that is we put a point at the y-intercept of b, then we attach a slope of m to it to get more points, connect up with those points with a straight line. All right, so step three, we will, so we graphed each equation. So we've got two lines on our graph right now. We want to circle the point where the lines intersect and write the coordinates to that point as our answer and box it. Okay, we can do these steps for problem number one. So both equations are already in y equals mx plus b. So let's graph this first one. It has a b value of 2. That means it's going to cross the y-axis at 2. Notice a little y there. That reminds you that this is the y-axis. The slope is -1, so I can turn that into a -1 over 1, which tells me that to get more points, I can go down 1, right 1, down 1, right 1, down 1, right 1, all the way across the graph. Or put that negative on the bottom. That means go up 1, left 1, and you'll see that keeps me on a straight line. These are some points that are on that first line. We'll connect them up, show where the rest of the points are. All right, let's do the same thing with the second one. It is a y-intercept of -4. We always start at the end, so we'll start with that -4 by putting a point there. Its slope is -7. We'll turn that into a slope we can graph by making it -7 over 1, which means go down 7, right 1, or reverse it, go up 7, left 1, and we'll hit this point right here. So this only hits those 2 points, but that second point was a point that our first line shares. So we're going to go ahead and circle that point and say that our answer to this system of equations is the point -1, 3. Remember, always do the x, then the y. So I have to go over to the -1, and I'm going to go up 3 to get to that point. All right. So we're not quite done with our steps, though. Step 4, if the equations don't cross and are parallel, we're going to write no solution. Step 5, if the equations, or if, well, let's say like this, if the graph is the same line twice, in parentheses, we could say this is a coincident line. If the graph is the same line twice, a coincident line, then say infinite solutions. Infinite solutions. All right, let's try this with number 2. Put a point at the top one's y-intercept of positive 2. To get more points, I'll turn that slope into a negative 2 over 1. So down 2, right 1, down 2, right 1, down 2, right 1, or up 2, left 1. Connect them up with a line. On to the next one. It has y-intercept of negative 3, but it's got that same slope, down 2, right 1, or up 2, left 1. Well, because they have the same slope, we know they're either going to be coincident or parallel. But these have different y-intercepts, so they end up being parallel. So where are these going to cross? Well, trick question, these are not going to cross. We need to say that our answer is no solution. All right, what about number 3? All right, let's go through the steps. It's already in y equals mx plus b, so I can put a point at its y-intercept of negative 4. The slope is 7. I might turn that into a 7 over 1, so I know to go up 7, right 1. Those are the only 2 points that are going to fit on this graph. We'll connect them up with a straight line. Now to the next one, y-intercept of 4, slope of negative 1, so turn that into a negative 1 over 1, so I know to go down 1, right 1, down 1, right 1, down 1, right 1 to make this line, or up 1, left 1. Connect this up with a straight line, and we can see that these 2 lines do cross. This is just one solution, and that solution is right there at 1, 3. X equals 1, y equals 3. It's the combination of an x and a y that'll make both of these true at the same time. All right, you got a couple more on the back here to try. I'll just do 4 and 5 really quick. Won't really necessarily say all of my work out loud, but you can also pause the video, try these ones on your own. Number 4 is 1, 1. Too many parentheses on that. Number 5. Number 5, they have the same slope. So you almost don't need to graph it. If you see the same slope, different y-intercepts, you know these are going to be parallel and have no solution. And now for this last one. The top equation is easy enough to graph. Put a point at 3. The slope is 1/4, so go up 1, right 4, 1, 2, 3, 4. Up 1, right 4, 1, 2, 3, 4. Or down 1, left 4, 1, 2, 3, 4. Down 1, left 4. And we get those points that are on the first line. What makes this one a little bit trickier is that that second equation has been given to you in standard form, which is a little harder to graph. So we're going to need to convert it into slope-intercept form. 4y minus x equals 12. I want to add that x to both sides. Get 4y equals x plus 12. Remember to put it in front of the 12, so it's more like mx plus b. Divide both sides by 4. And we'll get y equals 1/4 x plus 3. Remember to pull the x off the top. And now I see, okay, I put another point at 3, same slope. These are coincident lines. So we have infinite solutions. Which doesn't mean that every single combination works. There just are infinitely many combinations that do work. All right, slight distinction there. All right, that's that for this lecture video. I'll embed a few more for you to try, and have a good rest of your day.